and I started teaching, and I did for 5 years at the Joke Smit College in Amsterdam. And in the second year, I also started doing a PhD in math education at the Radboud Docentenacademie, which is the department that does the teacher education program. And it's a collaboration with the University of Bonn, because my promoter is Rainer Kaanders, here with us today, and also with the mathematics department. The topic of my PhD is the teacher's work in mathematical whole class discussions. And of course, I will say a lot more about that today. My contract, if that's the right word, ended in January. So I started a new job as a vakdidacticus wiskunde, also in Nijmegen. Different department, the science education department, and I will work together with the mathematics department and again the Radboud Docentenacademie. And they started a new teacher education program where we used to do 1 year of mathematics courses and then 1 year of teacher education. Now they're starting a 2-year integrated program. And for this program, I will develop mathematics master courses with an orientation towards the job of teaching mathematics. All right. I'm going to start with presenting you this problem. It's from one of the most used mathematics textbook series in the Netherlands. And I would like to give you some time to think about the problem, what you would do to solve it, and also what you would expect students to do when they're asked to solve this problem. And by students, I mean students in Tier 5 VWO, so higher secondary school students. I'm looking for signs to see if anyone's finished. But of course you can go on and on. So once you start anticipating what students will do, you can go on and on, thinking what students could think and do when confronted with this problem. And I'm gonna start speaking again. Well, actually, I already started speaking again. If we were in a different setting, then of course I'm very curious what you all thought. And if we were in a different setting, I would have been able to walk around and monitor what lines of thoughts I could recognize, and I would be able to select specific people to present their ideas and to decide an order in presentations, and invite you to articulate connections between the different ideas that you all had. I'm not going to do that now, but what I am going to do is I'm going to take you through 3 different solution methods, starting with this one. I think most of you were drawing in the beginning, because the exercise did not include a drawing. But if you're making a drawing, then you already have to think about the problem. And one student used this kind of a trial and error method, drew several candidates for the given line, and measured to decide which one was the right one. And the answer he got is, well, it's very close to the actual exact answer. Now, one of the teachers I worked with used this problem, and actually several of the teachers after that did as well. So we're in a 5 VWO class, and the teacher has presented the problem to the students. They've worked on it, and several different solution methods have been discovered by students, and were drawn on the whiteboard. And the teacher is orchestrating a whole class discussion about these different solution methods. And the teacher asks this student to present his solution method. And what he says is this: I actually just measured, because you knew that point and you knew that the other point should be on the right. So I just drew several lines and then measured when the radius was twice as small as the point on the x-axis. Now, suppose we were watching a video, or we were there when this happened, then we would pause now, and like I do now, I would ask you what could happen now in this classroom situation, and what would you like to happen, and why? And I'm giving you some time again to think about this. What would you like to happen, and what could happen right now?
Chris, you want us just to think, right? Not to say anything.
At this point, I just want you to think. Yeah. This time I'm gonna invite you to say something as well. So anyone has an idea they want to share, something that could happen or that you would like to happen? This is my first online meeting as a presenter, so I'm not used to giving turns.
So I would like to point out to people that you can raise your hand if you go to usually the top of the screen. You'll find a number of buttons, two people next to each other, then a sort of speech cloud, and then a person with a hand next to it. There you can choose the hand. I'll press it for you so you can see what it looks like this. Chris, you see it as well?
Yeah.
So then that's the equivalent of raising your hand in classroom. And you can also lower it, which people usually forget. If you press it again, then that doesn't happen in classroom. You usually remember to lower it after you.
You can also lower other hands.
Okay, but now I see Adrianus, I believe.
Yes, that's correct. Well, your question was what you were hoping that the teacher would say after Jesper presented his solution. I thought that was your question.
Right.
And I thought, well, I would hope that the teacher would ask, what does it mean to be attentioned to a circle? So ask a question.
Right. Thanks. Anyone else? Let me see. Someone raised.
I see Mei Lee has raised her hand. Mei Lee?
Hi. I guess one thing, if I was a teacher, I might, if the student gave an approximate answer, I might ask something like, well, how can you be more precise? What relationships can you use to get at a more exact answer?
Right. And why would you do this?
So it depends on the goal of the teacher. I was guessing that the teacher, there was like a mathematical relationship that the teacher wants the student to get. And so the sketch it's like approaching the whole you would use one way you could use is the Pythagorean theorem, but maybe like if you ask them for more precision, then maybe like they start thinking more abstractly and like thinking about like, well, what numbers, how can I be more precise? And so maybe they come up with a Pythagorean theorem. But it depends on what the goal of the teacher is, I guess.
Of course, yeah. Thanks. A different idea? Rogier, you have your hand up as well?
Yeah, just more open. You could ask maybe the students what they think of this method to evaluate simply the approach. And hopefully then the students might say, hey, but you know, I found ways to be more precise. No, maybe they can, you don't know if students already realize that this is not an exact answer. You know, so then as a teacher, you have the opportunity to find out whether students make difference between exact answers or measurement.
Right. Any response to that? No. Okay. We're going to continue to another solution method. It's this the visual representation of the students that they put on the whiteboard. And I don't know if you recognize this solution method. It involves making an equation for the circle, making an equation for the line, and substituting the one in the other. Then you get a quadratic formula. Do you see my mouse?
Mm-hmm.
Yeah, okay. And the formula stands for all the points that are on the line and on the circle. And because it's a tangent line, there should be only one of those points. And because it's a quadratic formula, you can find when it has only when there's only one solution by calculating when the discriminant equals 0. And okay, I'm gonna. So this is also one of the solution method. The teacher asked the students to explain their solution method, and this is what one of them says. We made a formula for line L, Next, we substituted that formula in the formula of the circle. Then we calculated the discriminant, and then discriminant equals 0. And again, I'm inviting you to think about what could happen now. What would you like to happen and why?
Let's see, Mei Lee has raised her hand again.
Can I ask a question, like before I give my response?
Of course.
Are the students working in groups?
In this situation, they were seated in pairs. So they first were thinking individually, and then in really small groups, like 2 or 3 people.
Okay, so I guess like if I was a teacher, one of the things I might do, or I'd be interested in doing, is like I like that they come up with different methods, and so have them like is there another way you can solve or like share? Like this one, they use the formula of the circle and the formula line, and so they took a very algebraic approach,
right,
to solve this. And the first group, or the first one that you showed, they took more of a geometric sketching. I mean, they both made sketches, but the other one didn't feel the need to go for precision. And this group seems like they can get a very precise answer going this route. And so as a teacher, if they were working in groups, I would want them to like, and I don't know if they did this on paper or whiteboard, but like share between the different groups the approaches, and like talk about like compare the different approaches to see like sort of like multiple representations in science, but like multiple representations in math, that like they're both like appropriate ways to get to the correct response, but different ways.
Yeah.
I don't know.
So that's one of the goals of the teachers who try this, that after presenting these different solution methods, the goal is to get the students to articulate connections or differences between the different methods. Yeah.
Okay.
And now we're still in the first part of such a whole class discussion, where they present their solution method like this. So I'm asking for more micro action from the teacher. Like, what would you like the teacher to do right now? Is there anyone else who wants to share a possible action for the teacher?
Yes. Anna starts. Anna.
Yes, so maybe I would ask if other students in the class have an idea why discriminant needs to be 0.
Right. And why?
Why to act like that? Because it's interesting if everybody can follow the method, and that would be kind of it could initiate a discussion of each other's understanding in each other's thinking.
Yeah. Okay, thanks. Rogier?
Yeah, I see Lonneke first.
Oh yeah,
maybe.
Lonneke.
Okay, well, I would also be interested in confronting the class with the differences. So the other one got a rough approach of 3.5, and here we have a totally different answer. Is there anybody who can explain why we have this different answer? So it depends a bit on the goal of this lesson, but it would provide me with an opportunity to look at fractions.
Oh yeah, right. Okay, let me say 2 things about this solution method. There's a calculation error in there somewhere, and she was aware of this, so she said that as well. And well, the technique of using the discriminant and see when it equals 0 is a technique that is used a lot in these textbooks that these teachers use. Okay, that was what I wanted to say about this, and let's the next one is also interesting, because this is the solution method by the teacher. It's a geometric or geometrical solution method involving similarity of triangles. And the teacher anticipated what students would do, and he found different solution methods beforehand. And this was one that he really wanted to be part of the discussion, but no student came up with it. So he put it on the whiteboard himself. And at a certain point, he asked the class to look at it, and he asked if anyone could explain the method. And that says this, it's with those ratios, right? With a triangle that has an angle of 90 degrees, then you could work with, if one side is twice the hypotenuse, and then you could work with the ratio. But I don't completely remember how, but there's something there. Okay, take some time to think. What would you like the teacher to do now, and why?
Yeah, maybe Mei Li again.
Hi, sorry. Okay, so I think if I was a teacher and Ted said something like that, I might say like, well, what do you remember about ratios? So first, like establishing what it is that the student, he says that I don't completely remember how, but there's something there.
Yeah.
And so then I think as a teacher, I might say something like, well, what specifically do you remember? And like have them apply it to the ratios that are shown in the triangle right now.
Yeah. Okay, thanks. Rogier?
Yeah, I thought maybe if this is really the learning goal around here, then maybe they could reproduce this this approach themselves. You know, take some time with it, because this sounds rather vague. So if they work in groups, they could maybe spend some more time on it.
Right. Yeah. To give them some thinking time to consider this solution method, and then you mean the solution method of the teacher, the one that's on the whiteboard.
Exactly. Yes, if that's important for this lesson. Yeah. It's good to have some time with it.
Anyone else something to say about this student comment and what a teacher could do? Okay, I'm not going to point to people who don't volunteer, but I would if the situation was different, I would, but I won't do that now.
I could do it for you, Chris, if it makes you feel uncomfortable.
Oh, yes, please do. Just select someone. Yeah.
Yeah, Angeliki, our speaker from next month. A good opportunity to show herself. Angelika, what would you like to say here?
Thanks for making me, for volunteering me. Well, at this point, I wouldn't add something, but let me think a little bit more about it, and I'll tell you.
Okay. Let's continue. Discuss, we're still in the introduction, right? Well, what we just did, we were thinking about what you could do as a teacher, and of course, this also includes making sense of the thinking of the student. And in making sense of the student's thinking, if you do that, you're thinking mathematically yourself. So making sense of student thinking involves mathematical thinking on the teacher's part. And the role of teachers' mathematical thinking in their sense making of students' mathematical thinking, that's the focus of this the study that I'll present here today. And what I did now is what I did with teachers. So we watched videos, and I paused after certain student statements or contributions in the whole class discussion, and then I paused and I asked them, what would you do now and why, or what could happen now? So the research question of the study I will present is, what's the role of teacher mathematical thinking in making sense of student mathematical thinking? And I'm going to give you a quick overview of my PhD research about the teacher's work in mathematical whole class discussions. the first study, I collaborated with one teacher, and we developed 4 lessons that involved whole class discussions. So we sat down together and we prepared, and then she would enact the lesson, including a whole class discussion, and I would be there to observe and to videotape. And after that, we would evaluate and reflect on the lesson using the video. And in the study, I investigated her role in the whole class discussions and how her role changed throughout the 4 lessons that we developed. In the second study, I organized a workshop, klassengesprekken in de wiskundeles, a workshop about whole class discussion in mathematics lessons. And 7 teachers joined from throughout the Netherlands. And it was a 4-hour workshop. And after the workshop, I visited all of them to observe and videotape one of their first discourse-based lessons. So one of the first times they actually tried orchestrating a whole class discussion about different solution methods. And after the lesson, I sat down with them with the video to investigate their decision making in the moment of teaching, in the moment of orchestrating whole class discussion. So they're in the moment decision making, how they base their decisions on their interpretation of the students' thinking and their underlying personal conceptions. And then I finally found a group of teachers who wanted to work with me intensively. 5 of the teachers from before, they joined me in a teacher-researcher collaboration that is still going on, but it was 1 year of very intensive work together. We joined every month at my university, and in between meetings, each one of them prepared one discourse-based lesson, enacted it, videotaped the whole class discussion, and evaluated it individually, and they sent me all the material, and together we selected certain parts of the videotapes to reflect on during the next meeting. So a big part of the meetings were video-based discussions in which we reflected on their own videos of whole class discussions. So the main goals of this teacher-researcher collaboration were developing better whole class discussions throughout the year, and developing some guidelines for teachers who want to learn how to orchestrate and develop and prepare whole class discussions. And just to show you, these are the guidelines that we developed together. It's in Dutch. Handreikingen, klassengesprekken in de wiskundeles. It's about deciding your mathematical goal, finding a problem, so that you think that if they work on this problem, then the things you want them to learn can emerge in their individual group work and in the whole class discussion. Making such a kind of a map. If you anticipate what students will do, you can think about which ideas you want to be presented in the whole class discussion, and which connections you want them to articulate, so that you arrive at the goal together and not just the teacher. And during the whole class discussion, you have to focus on student thinking. You have to consider the map that you made, the plan that you made, and you need a certain kind of interaction. You need students to discuss each other's ideas. And reflection is inevitable to develop this very difficult teaching practice, because it is. One example of one of the guidelines, finding connections between different solution methods is something that doesn't happen very often in whole class discussions that I've seen. Students are not used to this. I heard some of you suggesting this already, finding these connections, but it's not something that's very obvious for teachers and students. if you ask them for connections or similarities or differences, what they come up with is usually something like, I see square root of 4 minus x squared there, and I see it in that solution method as well. Or everyone drew the radius. These are kind of similarities that the students see between the different solution methods. And in our collaboration, in our work together, we realized that these similarities are not mathematical connections, but if you take them as a starting point of an exploration, they can lead to the articulation of mathematical connections that lay beneath the visual similarities. All right, current study. The research question, I already told you. I think a lot of research is interested in the knowledge that teachers need to support their students' mathematical thinking. And for me, this is kind of misaligned. I think it's more an interesting question to ask what mathematical thinking do teachers need to support their students' mathematical thinking. What I did in this study, I focused on the video-based discussions. And like I said, I often paused after student utterance and we discussed what could happen and what they would like to happen. And so this involved the sense making of the students' thinking. And yeah, I wanted to investigate the role of their own mathematical thinking in this sense making. So I investigated their sense making during these group meetings, and not in the moment, but during the group meetings. During the analysis, I just marked, the first step was marking anything that concerns student mathematical thinking. I found that in the first 4 meetings, they didn't really discuss student thinking, and I already noticed that during the work. So I changed the setup from the 5 meeting on. I did this setup where I paused after student utterance and asked them to think about what could happen, to focus them on the students' thinking. The second step, I analyzed their sense making. So when they were making sense of student thinking, I analyzed whether they were restating or investigating or evaluating students' thinking, and whether they were talking about the formulation of the student statement, the meaning of the statement, the intention of the student, so what they actually meant, or the reasoning that was behind the statement. And then I looked further in all this sense making. I looked for the role or for signs of teacher mathematical thinking in the sense making, and in the final step I investigated. So I just asked myself, what's the role of the teacher's mathematical thinking here in this sense making of student thinking? Are you still with me? Right. Okay, great. What I found was, well, overall, often the role of teachers' mathematical thinking does not become clear, because they often do not articulate mathematical thinking. But when they do, I found 5 categories of how the role of their thinking plays out in their sense making, and I will take you through these 5 categories. First, just to illustrate the first finding, often they were making sense of a student's thinking, but they did not articulate mathematical thinking. For example, when they say, the student said it wrong, but she meant it right, they're evaluating her formulation, they're evaluating her intention, what she actually meant. And well, hopefully this is based on mathematical thinking, but it does not become clear because they don't articulate it. Okay, first example. This in a different lesson by a teacher named Sigrid. She wanted the students to explore the function square root of x. She asked them, just investigate this, look for characteristics or properties. And her goal was to encourage the students to make connections between the different representations in the whole class discussion. So she wanted to bring out student statements that connect different representations of this function. So at a certain point, the table was on the board, and she plotted the graph with GeoGebra. So the graph was there as well, and she asked the class, I can see in the table that we cannot insert negative x values. Ferdinand, can I see that in the graph as well? Ferdinand says yes, because the graph does not go beneath the x-axis. Well, what would you like the teacher to do right now? Maybe someone wants to say anything.
Ask a follow-up question. What do you mean? Because you might very well confuse x-axis with y-axis. Oh, because of the x values.
Right.
So how do you see that in the graph?
Yeah. Paul?
Or maybe graph the function x squared and raise the same question.
Right, and why?
Because then the argument does not hold, because that graph doesn't go beneath the x-axis as well, but you can input negative values for
Right.
x.
Right. Adrianus?
Yes. Well, I would pose the question in the whole classroom. So there must be different students who think about it and don't want to say something. So maybe they know the right answer, and then they can help Ferdinand.
Right, thanks. Yeah, it's a very interesting student contribution, because yes is the right answer, and the graph does not go beneath the x-axis is also a correct statement, but it's not really an answer to the question, right? So the first thing that the teachers said when I paused it at this moment was, well, he just means not left from the y-axis. So the first thing is, oh, this means something else. And I think that happens a lot during actual classroom moments, that teachers just think, oh no, it means something else. But when we, Rogier, do you want to say something, or your hand is up? Your hand is raised.
Yes. I thought if there's still opportunity, because maybe this is where you want to go, but I think the teacher's thinking here is definitely important, because I think the question is not so very well posed, because of course the graph could be just the graph restricted to a certain domain or something. Can you see, what can you see exactly from this picture?
Right.
It's actually, there's a little bit of the x-axis left of the y-axis visible, but only a tiny bit. So there could very well be parts of the domain where where x is very negative, where there is parts of a graph. So I don't know. Maybe there's a little bit confusion also about the way the question is posed.
Right. Yeah. Thanks. Okay. Well, when we were discussing this, after after saying, well, he just meant not left from the y-axis, they continued thinking about the statement and what could happen. And one teacher, so everything that's in italics is the classroom video, and not italics, that's the group discussion of me and the teachers. So Jesse says, what you have to figure out, the student is reasoning based on the shape of the graph. He uses that to predict the rest, I think. And then Anna says, the strange thing is there are 2 points. So this also refers to what Rogier said, or similar. you have an endpoint on the left, but you also have an endpoint on the right, because this is just part of the graph, and we don't know whether they mean left on the left or on the right. And later Jesse says they start reasoning dynamically, like the student maybe think that this graph arrives here in the origin, and then it should continue like this smoothly, like it has been rotated. So the point here is that they move beyond the first initial interpretation that the student meant something else, and they start reasoning about thinking that could be behind this statement. So they take the statement seriously, and they start reasoning about the student's reasoning. So the content of their own mathematical thinking is supporting them in making sense of the student thinking, in adopting the student's perspective and trying to figure out what they could have been thinking. So it helps them in being flexible. And something else that can happen is maybe kind of the opposite. We recognize this solution method from earlier. It involves similarity, and the teacher really wanted this to be part of the whole class discussion. And then student says, it's with those ratios with a right angle triangle, and one side is twice the hypotenuse, then you could work with the ratio. Now, well, it could be that this student is remembering something about the standard triangle of 30, 90, 60, because he says here one side is twice the hypotenuse, which is obviously incorrect, but one side is half the hypotenuse. That's the ratio in the standard triangle that you could use here. And this hunch that this student has could lead to another solution method that has not yet been shared by students. And of course, in the moment of such a whole class discussion, it's very difficult to realize, and to make sense of this thinking, and to decide to explore this hunch, and to arrive at a different solution method. And maybe you don't want that at all. But now we were in the group, and we were watching the video, and then I paused it after this student statement, and we discussed what could happen now. And where a lot of us were investigating the hunch, like maybe he was thinking about the standard triangle, because we, as the group of teachers, we had already discussed such a solution method earlier in that meeting. But the teacher who taught this lesson, Jesse, he kept getting back to his solution method involving similarity. So, like the last statement, I think that he sees that if you go from OC to OA, that's 2 times as large, and that must be the same as from the smallest leg to hypotenuse times 2. So OB is 4, then AB is 8. That's what he's saying, I think. So while we were discussing that maybe Ted was thinking about something else than these similarity ratios, Jesse kept, he stayed a bit preoccupied. He still wanted to, it seemed like he still wanted to hear about similarities. So here, the content of his own mathematical thinking is not supporting him in being flexible, in adopting the student's perspective. And he seems a bit preoccupied. And later on, he acknowledges other possibilities. But at first, he seems preoccupied, even when he's outside of the actual teaching moment. Another possibility is that a teacher doesn't understand what a student is saying. We already saw this example as well, and well, one thing that could happen is that the teacher doesn't understand, and that's what happened in the group. In our group discussion, one of the teachers said, just please show me again what it is that he does, because I still don't understand. So if in case of incomprehension, this can of course obstruct sense making, because it can make you stop in trying to figure out the student's reasoning, because you don't understand it. So it can go both ways. It can make you stop, or it can make you well, acknowledge the incomprehension and make it public, and take the group discussion as a way of exploring the mathematics. And this could also happen in a classroom. You can make your incomprehension public and use the whole class discussion to resolve it. This example we also discussed previously. Well, like I said, this is a technique that they have to do a lot, or of course they don't have to do it a lot, but the textbook uses it a lot, and so the book with solution methods also uses this technique a lot. So during the group discussion, the teachers, like one of you also said, a good question would be, why must the discriminant be 0? And we started discussing whether maybe this technique had become a routine for these students. Yeah, because perhaps they just learn, okay, I need to apply that, so I'll just do it. And another teacher says, that seems logical to me. If you've done it very often, then it becomes discriminant equals 0. Yeah, that's just the way we do this. And it's not necessary to always think about why it works. It's just like riding a bicycle. Something you just do. You've learned that once. So this was a very interesting discussion, because, of course, when you do something very often, it becomes a routine. And for you and me, many of us, if we use this technique, we don't explicitly think through all the steps of the argumentation why it works in this case. But the thing here is that this teacher seems to project his own way of thinking, his own the process of his own thinking on his students. But the students, they are still learning this mathematics, and they're still learning about this technique. And well, a whole class discussion is a good moment to help them articulate their thinking and reflect on their solution method. So I think that Jesse, with all his experience, because he's a math teacher, he's just like us, he has developed an intuition about when this technique works. And of course, the students also have an intuition, but our intuition is based on a lot of experience with reflective thinking, and the student's intuition is more initial. And if you don't recognize the gap between these different ways of thinking, then this may be impairing in making sense of the student's thinking. So this is the category I called projection. They project their own way of thinking on students and seem to disregard the difference in experience. And the final one is consider regards the same example and also the same discussion when we were discussing whether it could have become a routine for the students. Another teacher said, yes, I think the teacher's role includes asking why, because there's a line of reasoning that's behind the possibility to use this technique. And if the situation is different, you want them to be able to reason in the same way, even if it's not about a circle and a tangent line. Then their use of this technique must follow from the reasoning and not from a routine, an automatism. Discriminant equals 0, right? So here, this teacher is taking her own way of thinking mathematical and using it as a model for what she wants to develop in her students, and a model for looking at what her student, she's looking for signs of, you can use your own thinking as a way to look at science in your students' thinking for if that thinking is already there, if you know what I mean. So she uses her own way of thinking mathematically as an example for what she wants to see and wants to develop in her students. So this categorization that I found in my data, we can see that some categories involve the content, the mathematical content of their thinking, that what they are thinking about right now. And some examples involve the process of their thinking, their way of thinking. And sometimes it's supporting the role and sometimes it's impeding. Now for my final slide, these findings suggest that making sense of students' thinking requires teachers to, of course, listen very carefully to what their students are saying mathematically, but also to re-examine their own mathematical intuitions and to reflect on their own process of mathematical thinking. So teachers need a certain awareness of their own mathematical thinking to be able to make sense of their students' thinking. I think this categorization can hopefully be confirmed and expanded in other studies in other contexts. And I hope it can also help in developing a conceptualization of teachers' mathematical thinking, because I think that's much needed. Can also be adopted by teachers or people who help support teachers to investigate the role of their mathematical thinking in their sense making. And this is the end of my presentation. Thank you very much for your attention and for your remarks.
Thank you very much, Chris. I really enjoyed this presentation, and it was not just presentation, it was pretty interactive already. But now we're up for even more interaction. I see some applause. Some people have found out that you can actually applaud.
Yeah, thanks.
Using the same button, and rightfully so, I'd say. There are more claps there. Wonderful. Excellent. So the idea with our seminar is not just the one-way traffic, but definitely interaction and discussion. So we've got half an hour left for any comments, question, remark. So please feel free. I see some hands. Of course, you can see it as well, Chris, but I see hands lifted by Mieke, by Mai, by Michiel. Oh, Michiel.
Great.
Yes.
Great.
So maybe Mieke could ask you a question. I don't know, Mieke, we see an orange blob on your screen and your microphone is still off.
Yeah, my microphone is on. Sorry.
All
right. During your talk, I was thinking about that teachers need a skill that they can make up different solutions for one problem. And I think it's a kind of practicing that when you have a problem that you try to find different solutions so you are prepared to the different solutions students may come up. And I think that's very worthwhily to have that skill as a teacher.
Yeah, and the good thing is that you, well, it's very good to be able to prepare yourself for the different lines of thought that can happen when you confront students with any mathematical question. I mean, students are always thinking different things. So it's good if you already have thought about different solution methods. It's also it's not that easy, especially in the beginning. The thing with finding a mathematical solution is also that everything falls into place, kind of. And to take a step back and to to think of a different solution method it takes some practice. But if you start doing these kinds of things and you start really listening to what students say, then you learn a lot about the variation in solution methods, and so you get better in finding different solution methods as well.
Yeah, and I think also questioning students, that when you are asking students to explain their strategy, that you are not tell too much. You know, for example, with the discriminant equals 0, I would have asked, suppose the discriminant is 2. What is then the situation? Can you think about it? And all these different type of questioning students, that's also, I think, for a beginning teacher, very difficult.
Right, yeah. It involves a lot of different aspects, this work, the teachers work in such whole class discussions. Already the anticipation, articulating your mathematical goals very clearly in the shape of student statements that you want to hear in a whole class discussion is already challenging. And well, and of course the establishing the norms necessary in such whole class discussions, and thinking about the right teacher actions at the right moment to make sure everyone participates and that they discuss each other's thinking, and that you don't go on after each solution method thinking that everyone understands, but you find ways to get a better view of how all these different students understand the things that are being discussed. So it is indeed a very difficult job, and it has a lot of different aspects.
Yeah, and one thing, just very briefly.
Sorry, Mika, one last comment, please.
Oh, she stopped. Oh, there she goes.
No. Students are not always interested in solutions of other students, and I think it's a kind of attitude that you have to train your students, that they find it interesting or they can learn from it, and I think that's a challenge.
Right, definitely, yeah.
And Michiel.
Yeah, so thank you also for the nice presentation. I think you're still sharing your screen. I don't mind too much, but I see myself mirrored.
I thought I stopped.
Yeah. Oh.
Yeah.
Okay.
We don't see it.
Okay.
Well, of course, these problems are really nice and I think helpful for education, but you cannot have a whole class discussion with every problem. So I was thinking about the relationship between tasks and the variety of student responses and the potential in their responses you might expect. Do you have any ideas about that? You could think of like low floor, high ceiling tasks or other kind of tasks so that might also be a separate skill related to this. So how to predict that for a certain task, it might be very valuable to try a whole class discussion. Or
yeah,
did you take that into account?
Yeah, I think what the two examples that we saw were already very different in their potential of resulting in different lines of thought. I mean, the geometry problem, there's a lot of different ways to look at this, and the other one's just, well, investigate this function. So the variation concentrates on happens in a smaller variety. There is just the different representations involved in this function, and of course, if students are still new to, if it's a new subject, then they definitely have different things that they think, and I think that each question can be dealt with in a whole class discussion, except when it's simple yes or no question, of course, but even then you can still ask why. But the tasks, there are tasks that that come with an expectation of very different ways of solving it, and there are tasks in where this variation that you can expect is smaller. Yeah.
Okay. Yeah.
Okay.
And I think
right.
I think that mathematics, if you know what mathematics you want them to learn, if your goal is they should be able to solve this kind of question or problem, that's a different kind of goal than I want them to make these mathematical connections. So if your goal is of the second kind, you want them to make certain mathematical connections, then you need to think of a problem so that if they work on this problem and you expect different kinds of looking at it, then the mathematical connections you want them to make can be made when looking for connections between these different solution methods. So the task is very vital in your preparation. Yeah.
Yeah, I think too. Yeah. Depending also on the aim you have with the discussion.
Yeah.
All right, so I see 4 more questions. I'll take them. I think they arrive here in order of when people raise their hands. So that would be first Mai, and then Peter, and then Paul, and then Angeliki. So Mai.
Okay, hi. Thank you for your presentation. I do have a question about your next to the last slide where you talked about the ones that were supportive, the practices that were supportive or impeding. Right. One of the questions I wanted to ask about was the relationship between the teacher and the students in the classroom. And I'm wondering, like, the ones that you identified as impeding, like, for instance, I think projection was one that you had listed as could be impeding of the math teacher's understanding of student sense making of the mathematics. If projection could also be supportive if the relationship between the students and the teacher was such that like they feel comfortable or safe enough to say, like, no, teacher, this is not what I was saying, or like if they would speak their minds. Can you say a little bit about the relationship between the students and teacher in the classrooms?
In the classrooms, in my studies.
Yes.
Yeah, it also varied a lot among these 5 teachers. Is very, very different, the relationship they had with their students, and of course this is also a very important aspect of your teaching and of anything that you do with your students. So if you're still figuring out how to keep the class calm and such kind of things, then it's very difficult then your orchestration of whole class discussion will inevitably focus on keeping all the attention there, and that takes so much of your energy that you don't really have too much time to make sense of your students' thinking. So it helps if you have a good relationship with your students. About the projection, what you said was maybe it could help as well. I think well, if students if students react to anything a teacher says by stating, this is not what I meant, or this is not the way, or no, my reason is different than from what you're saying right now, or something like this, that of course then something that impedes, if a teacher is impeded in making sense of their students' thinking, then if this becomes clear for the students and they react by saying that it's actually different from what the teacher says, I mean, that's great. But the teacher might still have been impeded in sense making the moment before. But if the students recognize this and resist, I mean, that's great.
Okay, I guess I was curious about, like, when you say supportive or impeding, you're saying supportive or impeding from the teacher's point of view?
Yeah, supporting or impeding the teacher in taking the perspective of the students, in putting themselves in the students' shoes and really thinking about what could this student have been thinking. In this process, this is the sense making I mean, and in this process they can be supported or impeded by their own mathematical thinking.
Okay, great, thank you.
Okay. Rogier, who's next?
Peter, but I saw him reaching for the mic button.
Okay.
So,
yeah.
Well, it's actually a small remark, but I was a bit surprised about the fact that that one teacher, well, put up the whole solution with the triangles on the board, and actually, well, by doing that, well, a lot of opportunities were actually missed for classroom discussions, and I think, for example, the first student solution could be very nicely worked out in such a classroom discussion to that well, solution of that teacher. But by just putting it on the board, well, actually, well, the whole process was more or less spoiled. Was that also seen in this way by the involved teachers, or?
By me, yes, but I never really said it like this to them. No, I actually think that some of the other teachers thought, this is a good idea, I'm gonna try that. And if this happened, then I let it happen, because I didn't want to put my vision on it too much. So I think others have tried it as well. So I hoped that they would try it and would realize that opportunities were missed, if you know what I mean. Yeah. The teacher was very surprised that nobody came up with these geometric solution methods. And he asked the students at the end of the lesson, why didn't you come up with this? And then the students just said, yeah, that's not this chapter that we're working on. Yeah. So they had these geometry things were the year before. Yeah. And other teachers tried it as well in their 4th grade. And these students came up with a much wider variety of solution methods than the students in the 5th class. There was also another one who did it in the 5th class, and every student was trying the discriminant equals 0 method. So the 4th grade students were actually better. For them, it was an easier problem than the 5th grade students.
Yeah. Very interesting. I think the order has changed now on my list, but I said Paul first, so I might as well stick to that if he doesn't mind.
Well, I did it on purpose. I thought to give priority to guests like Angeliki.
Okay, all right, yes. Angeliki.
All right. So thank you so much for this very interesting presentation. I'm very interested in your theorization of mathematical thinking for your study. So what I'm wondering is, and probably I missed that, what are some connections with literature and mathematical thinking that you use in order to understand this notion? For example, do you use habits of mind from Kwok and colleagues, or thinking mathematically from Mason and colleagues? So this is one, and then the other one is, so if we think of your findings and the data, the rich data that you analyzed, From your analysis, in the end of the day, what do we understand about mathematical meaning? So what do we know about mathematical meaning? What is it in the setting of your study?
Can you further explain your second question?
Yeah, so in order for me to understand mathematical thinking, I would probably look at literature to see how mathematical thinking is explained in literature and whether such an explanation could connect with the context of the study that I would do. So that would be one. And another one would be that I would try to theorize mathematical thinking through the understanding of my data. So I'm asking you about some insights into mathematical thinking. What could mathematical thinking may mean in the context of your study?
Right. Thank you. You didn't miss it. I rarely said anything about theory during my presentation, or maybe nothing at all. But the theory of, well, my introduction of looking at mathematical thinking, I do refer to a lot of the, I don't think I refer to habits of mind, but a lot of the models there are for mathematical thinking that are usually like a list of smaller activities, right? Like problem solving or logical reasoning or abstracting. So I do mean all of those things, but I don't mean them as separable categories. My way of looking at it is that mathematics is an activity, is a human activity, and this activity is what I mean by mathematical thinking. So I was looking at it in this very broad sense, if that's any answer to your question.
Yeah, sure. So I'm thinking of future research, and probably for future research, it may be interesting to see what are some kinds of mathematical thinking that are present when the teachers are trying to make sense of what the students are articulating, and then see the connection between those kinds of mathematical thinking with the sense making, probably.
Yeah, I think that's a big gap in the literature. A conceptualization of teacher mathematical thinking that's involved in making sense of student mathematical thinking or in teaching in general. Yeah.
I think Thompson works on meaning making for the teachers do as well, but then it's called meaning making. But it's not my turn really. It's Paul's turn. If this interaction between you and Angeliki is finished.
Yes, sure.
All right. Yeah, Paul.
Well, anyway, I regret that I gave priority to Angeliki because I had similar questions, of course. No, seriously. Thanks for your talk, Chris. I appreciated the examples, the tasks, and your fine-grained analysis. But I think in line with Angeliki's comment, I have a difficulty in zooming out, so to say. For example, it seems that the slide with your categorization is a nice kind of synthesis or summary or maybe main result. But to me, it was not clear. Maybe I missed it. What is it a categorization of?
Right.
What are you categorizing?
Well, it's a categorization of. Let me take you to the slide. Do you see it now?
Mm-hmm. Yes.
Okay.
Mm-hmm.
Yeah. It's a categorization of how the role of the teacher's mathematical thinking plays out in their sense making. So.
But if you want to describe the way in which mathematical thinking, well, what was your phrase exactly? Sorry.
it categorizes the way the teacher's mathematical thinking, well, the role of their mathematical thinking plays out in their sense making. So
but you didn't tell us what you mean by mathematical thinking, I think.
Right.
So and it appeared so. I'm as Angelica. I'm a bit like. I would like to be a bit more precise on what this schedule really, or this categorization is categorization for, and how it is embedded in your views on what the key concepts mean, like mathematical thinking. Or another example is orchestration. You may use the word a few times, but so maybe this just, you don't have the time to tell everything, of course, in the presentation. Yeah. But I was looking for this kind of underpinning. So if we take an example of flexibility, how do you see flexibility as mathematical thinking coming for?
Yeah,
was not there.
Well, the only theory about mathematical thinking that you see in here is the distinction between the content and the process. So that's a very broad difference, and flexibility is in the row of the content, because if the content of teachers' thinking, and I mean in the moment of their sense making, so that's the difference with knowledge. I mean the content of their actual mathematical thinking during sense making, if it involves different lines of thought and connections between these different lines of thought, this helps them in being flexible, in taking a student's perspective, in trying to take the student's perspective and trying to figure out what the student could have been thinking. So that's the way I read this this scheme.
And incomprehension, for example?
Incomprehension is if they do not understand the mathematics in the student statement, that involves the content of their thinking as well. They don't understand the mathematics. It stops somewhere. Then it can go both ways. It can stop them from making sense, and then it's impeding, or it can lead them to making this incomprehension public and try to figure it out together with the students or the other teachers, and then it's supporting.
But that's not caused by their mathematical thinking, or is it?
No, but the incomprehension is caused by their is a part of their mathematical thinking. It just, their mathematical thinking stops somewhere, or it doesn't connect.
Okay. Well, there's the next question by Anna, but I would appreciate to have these type of things that we are discussing now a bit more clear and a bit more theoretically underpinned.
Right.
As far as I could see it in this presentation, of course.
Yeah.
Thank you for your comment.
Thanks.
Anna.
Thanks, Chris. That was quite insightful for my thinking, the presentation. And from the discussion that you also had now with Paul, so I see this table as a kind of an attempt to catch how well teachers' thinking can be aligned with the student thinking. And you kind of offer the categorization to understand if they manage to align or not. But I'm actually wondering, is it always that teacher needs to get into the meaning of a student's utterance? And if a teacher always intends to do so? Because I can imagine that this impeding, like pursuing your own, being preoccupied by your strategy and pursuing your own vision, it could be also a reason within the dynamics of the lesson. The teacher really needs now to speed up to his own vision, something like this. And I was wondering, is it like something just beyond the scope, or is this classification limited only to the situation when teachers want actually to understand what students say? And do they always need to understand? That's my kind of wondering.
Yeah, right. Thanks. I would say that this is indeed limited to, well, let me think about the first question first, because do they always need to make sense of their students' thinking? Well, ideally, I would say yes, because the student thinking, that's what everything is about. I mean, it's about what happens with the students. So their thinking, and even especially if they choose to articulate it and share it, well, I think you have the responsibility to try to make sense of it as a teacher. So I would say yes. And the second question.
No, I think that was more or less the same question. So you have, I would say that's quite radical, that we always need to go deep into the student thinking, because sometimes it might be just like not productive.
Yeah, that's.
I mean, I can appreciate very much this position, but I think it would be very interesting for me to somehow investigate the different dynamics within the lesson, when it is really valuable and when it's not.
Yeah, there's a whole line of research into these into categorizing the moments, or these moments or instances of mathematical thinking, and whether they are or are not if you should or should not take them as a basis for elaboration and further discussion. Like the word by Van Soest and Stockeroo, if it says anything, like it's in a similar line as what I do, but they go into some instances of student thinking are worthwhile and some are not. And it's actually a small part that is really worthwhile to base a whole class discussion on. So that's of course there are instances of student mathematical thinking that you should not really get into, but deciding not to get into it does involve some sense making. You have to make some sense of it before you can decide, I'm not going into this.
Yeah, that's a good point. Yeah, that's a good point. Thanks. Yeah.
Kuno, you want to say something?
Yeah, I can't find the symbol, but Chris, thank you very much for this interesting talk. And I like this idea of anticipating on student thinking. And I think it's also very nice that you showed that there are two sides to it. There's a risk of being impeding, where it also can be supportive. And I think it relates very much to the notion of a hypothetical learning trajectory. But I also see a connection with instructional design. And I remember from the time that I was very active on that I had a colleague who always warned me, well, you are thinking of how you want the students to think. And his role would be to play the devil's advocate and thinking about other ways the students might think. And I think this is a nice idea, but probably could also play out between teachers trying to discuss possible options in such a situation. And I think in the end, asking students to clarify and starting discussions on that is a very powerful instrument. And in that sense, incomprehension, whether real comprehension or played incomprehension, is also very powerful. I remember a situation where the one who was teaching really didn't understand the student. And he showed that he couldn't follow. And then the other students starting helping him to understand. And that also was a very powerful way to organize a lesson, I think.
Yeah.
So I think it's an important topic, and those two sides are something you have to be aware of.
Yeah. Thanks.
Which might be a nice concluding remark, since it's 5:02. We try to be very sort of fluid with the ending of this. I've many times tried to suggest we get ourselves a drink and have a reception, a borrel, in good Dutch tradition. Well, I think international actually. Instead of just stopping. But yeah, I hope, Chris, first of all, thank you so much for your presentation and for answering the many, many questions. It was a real pleasure, very nice to attend. And I'd like to also welcome everyone here for next month's meeting with Angelique Mali, who's here with us today as well. I just threw the abstract also in the chat, but for those who like to look at it just somewhere else, it will also be on our website, and I think I've already sent an invitation. And one other announcement, that's Peter Boon, I believe. I'm not sure if he said yes already, but since he wasn't there to give his talk last month, we have invited him to give his talk somewhere in June, I believe. So this is sort of a pre-announcement then, maybe. All be patient, and Peter will reward you at some point, I'm sure, in this seminar. So that's it. I suggest stick around, but maybe get a drink. And if you don't, then I'm very happy to welcome you again next month. Same place. Here, Reiner's got the idea. That's it. That's it. I hope Chris will stay around for if there are any more questions.
I will. And thanks everyone for asking questions and listening.
Cheers to that.
Thank you. Thanks.
Goodbye.
Goodbye.
Mm-hmm.